All right, today we're going behind enemy lines to really demystify one of modern medicine's most powerful and maybe most misunderstood weapons, chemotherapy. We're going to get into the cellular war itself, how these drugs actually hunt their target, and the brilliant strategies doctors use to win this fight, one cell at a time.
And this, right here, this is the fundamental question. It is the tightrope walk that defines everything about chemotherapy. You're fighting a battle inside the body where the enemy, the cancer cells, look almost identical to the civilian population, our healthy cells. So how on earth do you design a weapon that can tell the difference? Well, to answer that, we first have to understand the battlefield itself. And in this particular war, the battlefield is the life cycle of a single cell. Every cell in your body, whether it's skin or liver, goes through this constant process of growth and division.
Think of this whole cycle as a really tightly controlled four-step dance. In G1, the cell gets ready. Then comes the S phase. That's the crucial DNA copying part. G2 is like the final systems check. And M, that's mitosis, the grand finale where one cell splits and becomes two. Now, cancer. Cancer is basically this process with the brakes completely cut. It's an engine that is just stuck on go, leading to totally out-of-control division.
And that right there, that reveals the core strategy. If a cancer cell's greatest strength is its ability to divide nonstop, well, that's also its greatest weakness. The plan becomes almost elegant in its simplicity. Attack the process of division itself, a state that cancer cells are in far more often than most of our normal, healthy cells.
Okay, so let's talk about our first strategy. This is a direct assault on the enemy's command center. It's DNA. If DNA is the master blueprint for absolutely everything a cell does, what happens if you can just go in and corrupt that blueprint? This approach is all about attacking the very source code of the cancer cell.
And here we have two classes of these DNA saboteurs, alkylating agents and platinum analogs. You can think of them as tiny little demolition experts. They get inside the cell and they physically damage the DNA by creating what are called crosslinks, which is like tying the two strands of the DNA ladder together so they can't unzip to be copied. This just scrambles the code, causes breaks, and makes it impossible for the cell to divide properly, forcing it to basically hit its own self-destruct button.
Now, the second major strategy is less about a direct frontal assault and more about crippling the enemy's logistics. So instead of hitting the command center, you go after the assembly line. Because, if you think about it, if a cell can't build the parts it needs, it can't expand its army. Simple as that.
For a cell to actually divide, it really needs two key things. One, the raw materials to build new DNA, and two, the internal machinery to physically pull the cell apart into two new ones. This strategy, it targets both of those critical components.
And this is where the strategy gets really, really brilliant. You can see two forms of sabotage here. First, you've got anti-metabolites like methotrexate. These things are basically imposters. They look just like the raw materials the cell needs to build DNA, but when the cell tries to use them, they completely jam up the entire production line. It's a supply chain attack. Then you've got drugs like paclitaxel. These are what they call mitotic spindle poisons. The spindle is this tiny machine inside the cell that pulls the chromosomes apart during division. While paclitaxel freezes that machine solid, arresting the cell right in the middle of dividing, leaving it with no choice but to die.
But, as powerful as these strategies are, they aren't perfectly precise. And this brings us to the really difficult reality of chemotherapy, and frankly, the reason it has such a notorious reputation.
The answer goes right back to that core strategy we talked about. We're targeting cells that divide rapidly. And the problem is, cancer cells aren't the only cells in our body that divide rapidly. This right here, this is the collateral damage. It's friendly fire. See, our bone marrow is constantly churning out new blood cells. Our hair follicles are always growing. The lining of our gut replaces itself every few days. Because these healthy tissues are also in a state of high activity, they become unintended targets. And that is the source of many of chemo's most difficult side effects.
And as if collateral damage wasn't enough of a challenge, there's another major one. Cancer isn't a static enemy. It's a population of cells that can mutate and evolve under pressure, and they can develop ways to actually survive the chemical onslaught.
This slide just illustrates the ongoing arms race perfectly. For pretty much every attack we have, the cancer cell can develop a defense. We damage its DNA, it ramps up its DNA repair crews. We send a drug into the cell, it can actually evolve these tiny molecular pumps to spit the drug right back out. We design a drug to hit a specific target, well, the cancer cell can start producing what are called trapping agents to neutralize our weapon before it can even do its job. It's a constant battle of wits.
So this is the crucial point. Oncologists aren't just lobbing these chemical weapons over the wall and hoping for the best. They are master strategists. They use really sophisticated tactics to maximize the effectiveness of these treatments while trying to manage all of those risks we just talked about. And timing is absolutely everything. For instance, neoadjuvant therapy is like a siege before the main assault. You use it to soften up the target and shrink it down, making the surgery more successful. Then, adjuvant therapy is like the cleanup crew that comes in after the main battle to hunt down any enemy soldiers who might have escaped, preventing them from regrouping and causing a recurrence down the line.
Now this next idea, this is one of the single most important principles in all of chemotherapy, the log-kill hypothesis. It basically means that a single dose of chemo, no matter how strong it is, can't wipe out the whole tumor. It can only ever kill a percentage of the cells that are there at that moment.
Yeah, just look at those numbers. A 99.9% kill rate. That sounds absolutely incredible, right? You'd think that's game over, but in a war fought against billions of cells, it's not enough. So if a small tumor has, say, 1 billion cells, killing 99.9% of them still leaves 1 million survivors. And this is exactly why chemotherapy has to be given in cycles, to repeatedly attack those survivors as they try to regrow, pushing the numbers down again and again and again until hopefully none are left.
And this is where the strategy gets even more clever, protecting the civilians. Doctors can use what are called rescue drugs to shield the healthy cells. So, for example, after hitting the cancer really hard with methotrexate, they can give something called leucovorin, which is a compound that only the healthy cells can really use to bypass the drug's toxic effects. Or they'll use a drug called mesna, which acts like a molecular sponge, soaking up a toxic byproduct from another chemo drug specifically to protect the patient's bladder. These tactics allow doctors to be more aggressive with the cancer because they know they have a shield to protect the patient. So, as we've seen, it all comes down to this. It's a constant calculation. It's a delicate, difficult balancing act between aggression and protection, between how effective it is against the tumor and how toxic it is to the person it inhabits. And really, this tension has been the driving force behind decades of cancer research.
And that, of course, brings us to the future. Every single lesson learned in this brutal cellular war is paving the way for a whole new generation of weapons. We're talking immunotherapies, targeted agents, personalized medicine. These aren't just more powerful bombs, they're smarter missiles. They're being designed not just for power, but for precision, to finally tip that balance for good in this incredibly critical fight.